Hello guys, how you doing today? My name is Zubem and I'm a senior software engineer. Today we're going to be discussing about backend architecture, backend systems. Basically, by the end of this video, you have a very clear concept of how backends work, as in terms of their utility, especially like the different parts and why you have them and like alternatives to them. Originally I'm a front-end engineer, but I've been able to contribute in several backend projects and would I say sub backend projects where you use tools like Firebase or Superbase or low-code solutions as well. But I've come to have a great understanding working with frameworks like Adonis, also working with Golang, other Node.js frameworks, Express as well, and things like that. So I'm just going to be giving you an understanding of how backend systems work, especially if you're a front-end engineer. You should understand these things to help you to have an appreciation of what's going on in the backend. And if you're a non-technical folk or a team leader or a project manager, it also give you an idea of how backend system works. So essentially, both front end, both back end, one of their main purpose is basically to give access to a resource, right? It gives access of a resource to an entity. Now, this entity, why I said entities, it doesn't necessarily have to be a user. It could be a bot. It could be like via things like service accounts. It could be an integration like another tool. Right, that's what I use that keyword entity. Right, so backend services, front end services basically facilitates access of resources to an entity. So now, I'm just gonna take a note here, and yeah, I just started using this tool, Razor.io. I'm not yet familiar with it, but let's see how it goes. So I'm just gonna put in some keywords here. First is the entity, which could be a user, could be a bot, could be an integration, could be a couple other things, right? And then the next thing is the resource, right? So this resource, depending on the product you have, this resource could be, let's say, could be um, something like um, files, right? Could be files, could be a process, like maybe processing ability. You want to convert those files. Um, it could be some kind of data or information about somebody, right? It could be an action, access to an action, a big red button. It could be a whole lot of things, right? Now, how do we now bridge the gap between these entities and resource? And that's why, in terms of our users, we usually have a front end whereby they have to interface with, put in their username, their password, and then interface with the front end application or the mobile application, and then make requests. Like that front end application basically make requests via the browser or the mobile app to the backend services and then get responses. So the next thing we need to think about is like usually when you want to request something, you have to go to a door post, you have to go to an address. Now that address basically, right, is what we call routes. And yeah, I'll make another video relating front end to back end. Front end is most like and back end, they are very, very similar in terms of concepts. But we're going to discuss that later. So they need to go to an address to be able to access that resource, right? And that address is basically what we call routes. Before we even get to the routes, right, usually there's a domain name, right? You know, you see developers sharing around subdomains like api.yourdomain.com or something like that. Usually there's a domain name, but those domain has subdirectories, right? Which basically address to different resources in that application. Right, so now we've established that there's an address where you have to go to get something. So when you're coming to actually request those things, sometimes you have to come with a parameter, right? So you're coming with let's say your request. Let's say you're coming with your request. It could be email and password. It could be search filters. let's say you are trying to get a list of files, you want to pick certain extensions or file types and things like that. That could compose your request, right? It could be a particular user ID or file ID, you know. So you are that address now, but you have a particular request. Now, when you get to that particular address, ideally in a proper backend, there should be some groundwork that is done before they let you into the resource you're after. And usually, the first thing that is done is there are a bunch of validations. Um, some people call it middlewares, or will I say validation happens in the middleware. There are some things that check your access if you have access, right? But it's all basically checking your request. It's trying to check your request. Who are you, right? So basically, we can call this process how will I put it? Validation. Let's even just say validation. Request validation. So what do I mean by request validation? You are coming to an address with a request, right? They want to know if who are you in the first place based on what has been defined in this address. Do you have the key? Does this your key work, right? So some of the things that we checked is maybe your token, right? Like when you've already authenticated to a service, they store a token on your browser. That's why you don't need to enter username and password all the time, right? So maybe they're checking your token, and the token gives them an information of who you are, right? Now they're checking the request itself. They could also be checking the how, like, let's say you want to create something, they could be checking your payload, if you have some kind of malicious input or the right input, or if you are missing something, you know, let's say valid uh, input payload. Let's say you're uploading a file and you shouldn't be uploading past a particular size. Perhaps you reach your quota. So let's say we are checking some form of quota check. So um all these things are basically, we could even call them checks. Let's say checks. Yeah, that's a much I think that's a much better way, right? Checks are done on your request, basically. Right? We can't just give you the resources. No, that's not how it works. So these checks could be done, like, ideally it should be done before we are making the resource prepared to hand over to you, right? But sometimes it could be done in between, or yeah, it could be done, like, depending on how you architect the backend, it could be done in different locations, but ideally you should do it before you are getting access or getting ready to bring that resource to the user, right? So the bunch of checks, you want to check the token, you want to check the payload, you want to check if they have access, let's say quota check on workspace. Maybe you want to check their workspace. Let's say even though you're making a request as a user, perhaps you're making it on a particular workspace or team account, right? So I need to check if you have access to do things like that. So permissions check, do you have permissions to do the action you're trying to do, right? So I like to divert a bit to, like, discuss the various kind of actions that are common when it comes to, like, accessing resources on the backend system. So types so some of these actions, right? Some just use an acronym called CRUD, right? Create, update, oh sorry, create, read, update, delete, right? But me, I do extend this read to list and get. And there's a reason why. You could be trying to get a list of files, or you're trying to target one file, right? That's why I do break it down myself. And sometimes I also extend the actions to um upload, trigger, etc. Like, depending on the complexity of the application, right? So there are a bunch of actions that you could do, or you could be interested in to get sometimes you're trying to get a resource, sometimes you're trying to create a new resource. So perhaps it's not just about accessing a resource. You might want to create a resource, you might want to delete a resource, right? You might want to trigger an action. You want to do an action, right? So the bunch of actions you can do via a backend system, right? So um, whenever you come over to the address, it's checking for the action you want to do. Is it available on this address, or do you need to go somewhere else? And then it responds appropriately, right? There are different kind of error codes out there. So responds with error code and message. Yeah, ideally you should also like respond to a message like why you are rejecting a request, or why, or some messages also come across when you have your resource successfully delivered, right? So these are the actions that you normally do when you're trying to get a resource. So we're done with the checks now, right? Basically we could also call this middleware. Let's just call it middleware. You're in the middleware section. Yeah, don't need to overcomplicate things. Yeah, middleware. So any check that is done in this part, like that doesn't go through, send you back. Like it will stop at this particular point, right? So let's just assume we can do a manner of checks in the middleware side. Now, after we've gotten to the middleware, we are now at what we call the controller, right? So the controller is, or the handler, some people call it handler, some people call it the action. So types of action, yeah, let's say these types of action. Then the action itself, which is the controller, the action handler, let's call it the action handler. Could also call it the request handler too. Action or request handler, right? So ideally, you've done all your checks before you get to the request handler, right? But some people still do some little checks inside of the request handler. Like for example, you might want to do a check on the resource itself when you've gotten it. That's something, some extra checks that you might still want to do. But at this point, we are sort of like um, going to a database to get something. We are adding something to a database. We are really moving something to a database. We are calling another service that is attached to our app, right? That is where integrations come in, right? Integrations. Yeah, I mentioned services. Mm, okay. Yeah, services. Yeah, I don't want to confuse. There are two kind of services that usually come on here. So I'm going to change this. Let's just call it infrastructure. So now this controller is basically the handler for this route. This address you are in is what's responsible for handling requests that come in there. Usually you have one controller tied to a particular address, but I mean you can have multiple routes, use one controller if you like, but you just have to handle the uniqueness there, you know. But the controller is basically responsible for now answering your request. What do you want to do? Do you want to create? Okay, then I'll do. Do you want to read? Then I'll do. Now the controller goes further to use things we call services, right? Basically like reusable functions or method that you could use across different controllers. So that's one of the beauty of it. Services are not limited to one controller, right? You could have a delete service. Some people go as far as possible as creating what we call repositories that tie to the different tables in your database, right? So like depending on the time you have or the scale of your project, you can even go deeper. Then some people do have what we call utility functions, helpers, you know, and libraries, and the list continues, you know. So all these towards fulfilling the request for you. Now, from here, I want to go into infrastructure, because the infrastructure is what facilitates access. Is no, no. The infrastructure is basically like where things happen, or what facilitates the smoothness or the delivery of your request or the resource you requested. Now, what do I mean by infrastructure? A backend basically is a bunch of instructions or business logic that's living on a computer somewhere on the cloud. Never mind, we have a bunch of terms that are going around these days as to how they are deployed, maybe via Docker, Kubernetes. You could be using serverless functions, and things like that. All those are just different terms of how we take our code from the GitHub, the central place where we different developers push to, taking it from GitHub, those files, right, processing it, and then keeping it on those computers, making it available to users, you know. So let's say now we are aware that our code is on the back end, it's running, it's active, right? So people need to get to that code. So usually, the first or one of the first things we set up in our infrastructure. Now you see how I kind of like connecting things, because it's not always like that straightforward, but you get the point. So the first point of code, when you usually have an idea or a problem to solve, um, is we go get domain names. Like most startup founders or most teams, they just go get domain names, right? So you have a domain name, but what do you do with a domain name? It's basically like your primary address for your resources, be it your web app, be it a landing page, things like that. But usually, okay, you bought this domain name from a hosting company, right? Which they usually provide you what we call DNS tools that can help you map. Like you can basically go to the server, right? Let's go back one step. Oh no, no, let's not go back one step. So there's a server hosting your backend code, right? So this server usually has its own address, right? Has own address. So how do you map the address to the domain name you've bought? That's what you could do in your DNS tool, maybe in the hosting provider, or you could use services like Cloudflare, right? Or in your server as well. There's what we call Nginx. You can basically kind of have what we call reverse proxy server. You can do a bit of managing there. You could extend it a bit, you know, to manage requests, or you could use tools out there. There's Cloud DNS. Amazon also has its own DNS management tools as well. So what they do for you is basically like connect your domain name with your server, such that when people go to those domain names, they're actually visiting your server, right? That's basically the importance of that. So we're still in infrastructure, but one of the things like these tools do for you, these DNS tools, like Cloudflare, is that they can help you block bots. If you have a static site or a website, they can help you host it properly. They do provide like a whole lot around security, speed of delivery of your files. Like they sometimes do have CDN delivery across multiple locations. Like they have multiple servers usually. So you want your site to be as fast as possible. You want to use such tools. You know, yeah. So now we have our server available, but do we have a database? Like, do we have a database where we are storing this data, right? And what actually makes your app interesting is that the data there is dynamic. I mean, you could make me a Figma, like, and then if whenever I did something, it disappears. Even in Figma, like while you're working, it's being stored somewhere, maybe your RAM, your computer RAM, and then maybe you store it in localhost. But then if I go to another place, another computer, how do I access it? You need what we call a database, right? The database basically bunch of tables. If you think of Excel sheets, like it's like an advanced Excel sheet or spreadsheet, you have a bunch of tables, they have rows and columns, and then you do store your data there. And there are types of databases. Most common, we have the relational, non-relational, NoSQL, SQL. Basically, one is more structured, tables, rows, and columns, and one is more like nested data types, like where you have um, key value pairs. Basically, like it could be a number, it could be a string, it could be is another set of key value pair. It could be a list or an array. So um, your database decision could be informed by, let's say, it could be informed by cost. It could be informed by the simplicity of your app. It could be informed by the requirements of your app. Maybe you need speed, right? And things like that. So that would inform what database you're using. But most times people use relational database like Postgres, you know, um, Postgres, MySQL, MariaDB, and the rest, you know. Um, yeah, there's MongoDB. Mongo, that's a NoSQL database, MongoDB. Yeah, let's not go too deep into that. Just think of it that this is where you store your data. So like your app is dynamic, you want to store data about your users, about let's say the files they uploaded, the music they are listening to, preferences and things like that. All those is being stored in the database, right? So I don't think there's anything much to discuss on database that will not be a deep dive. Right. So aside your database, sometimes you do notice like certain things are kind of fast on the application, or sometimes you require things to come back fast. We use what we call a caching system, right? Which, for example, Redis, Redis is the most common caching system that we have. But some people do cache in memory. Yeah, I like using memory a lot. Like you can cache on the RAM, like in your backend, just basically store a variable globally, and then, or you can use a package to do it better. So you can use Redis. Redis, the beauty of Redis is that caching is is distributed. Like you can have multiple servers calling Redis, and then it returns data a lot faster than the database most times. So, for example, a use case, yeah, let me explain caching. I don't think I did. So, for example, caching is like you want to store data in a place where they can be retrieved faster. And that could be because you want to improve UX, or where speed is important, you know, um, mostly for UX reasons, right? Mostly for UX reasons, but there are times where like speed is important, like for that data to, especially like financial data on the stock market or things like that, you know that is where we would employ caching. But a lot of caching actually goes on in applications. Even WordPress back then, like, had caching systems, and plugins. So caching is a common practice in like backend systems. Then you see some applications have search, but the search is very bad. So like most database have some kind of like search capability, but it's not usually exhaustive. Like they can find you something that is alike to the test you're searching for. But most times we need to have a search server, right, or a tool that allows us to do search properly. So how that would work is, whenever we're saving stuff to database, be it a post, be it some kind of resource, we also should be duplicating those resource in our search server, right? The search server usually has its own storage, like it stores it in its own computer or server, you know and so that it also retrieves fast. Like most of these search servers are like engineered specifically for search, so they are usually extremely fast, but you want to have them so that they can help you do mostly what we call full text search. They offer a whole lot of tools these days, like these days you have AI recommendation, faceting, filters, and all that. But if you want to have a very powerful search on your application, you want to have a search server. There are a couple of them like Elasticsearch, there's TypeSense, and some of them allow you to like host yourself for free. Some of them have like a cloud solution. TypeSense, there's a Melee Search, I think. Am I spelling it well? Might not be spelling it well, but yeah, there are a couple other ones out there, and you could also roll out your own search solutions if you have the time to code it up. Maybe you don't want something complex, you could code up your own search solution, and then host it somewhere. Right. So that is another thing that would need. Then we would also need a queuing system. So, what do I mean by queuing system? In some applications, or most applications, actions are done like instantly. You want to create something, you create it. You want to upload an image, you upload it. Like it's done like maximum 2 seconds. Everything is done, right? Except in case of like very huge files. But even files, right? Or let's say you have a process to do, right? Um, or you have a process to do. For example, um, 1 second. Let me be sure my mic is. Just want to check on my mic. Okay, it seems to be fine. So, for example, you want to convert a huge video, right? You might not be able to like wait on your UI to like on the page where you're converting that video for it to be done. You might want to go off and do other things. So, a proper application is not supposed to break when you navigate away. It's supposed to still be processing that video and perhaps send you an email or notification that says, oh, your video is ready to be downloaded. So you need a queuing system. And most times these tasks are like intensive, like they are CPU intensive or RAM intensive or GPU intensive. Like they take a huge amount of your resources, your system resources or the server where the like what you're doing is hosted basically. And mind you, the backend could be multiple computers. That is one thing with backend systems. You can have a whole lot of servers. You know, you can spin a whole lot of servers depending on the scale of the application, how many users are using it, how fail tolerant you want it to be, right? So for this queuing system, I think there are things like RabbitMQ, um, much other queuing systems. You could also use things like Cloud Task, like offered by GCP. You know, so like most cloud service has like one kind of ready-made queuing system you could use, but you could roll your own as well. You know, so they process this task in the background. They have a very huge timeout, so like the process doesn't stop. You should set a very huge timeout, and then when it's done, you should send a notification to the user that, oh, this thing you started is done, right? So yeah, these some examples: cloud, task, GCP. Yeah, so this is mostly like the infrastructure around backend code. There could be a lot more depending on what it is that you want to achieve, right? Depending on like the nature of your application, you know, you can have a lot more services in the background. Basically, all these services are just running a bunch of computers that have addresses and then they talk to each other within the server or within the infrastructure you are using. So ideally, you want to host everything in one place so that they can talk to each other as fast as possible, right? Yeah, but and you have something called microservices architecture, whereby you know you could split your backend into multiple services or computers talking to each other, right? All in a bid to deliver resource to an entity or the end user, right? So I didn't get to use the diagram section, but I hope this like just gives you a broad idea of how backend systems are structured. Later, I would like to go into this part, right? Just this part. I would like to go into just this part to give like a diagram explanation of how those requests, like with a good example of how you start from a request, you get to the controller, the server, the database, and then how that request comes back to you, right? So for integrations, what I mean by integrations is that your app, like most times these days, no app is an island. Like every app is talking to some other app about something. Like user data lives broad in different apps. So most times you would want your app to be in such a way that they could communicate with things like, let's say, Figma, Notion, the Google account, Google Calendar, Google Sheets, you know, to import data in, you know, maybe you're importing data, you're sending data there, or you are doing a backup or things like that. So integration is a very common thing in web applications these days. So your backend system needs to be able to account for that. You know, even in terms of authentication, you might want to authenticate with some other service that they use. Right. So yeah, this is a broad overview of our backend systems or architecture. I hope it has given you a clearer picture of how these things work. I hope in the future I'll be able to dive into code of how to structure your backend application. Structuring backend application, funny enough, is very easy thing to do, but you would want to do in such a way that is scalable, like it facilitates the scaling or it's modular, you know. All right, so now let me not talk too much. If you like this video, make sure you leave a comment or you share to your friends and then subscribe to the channel for more. Thank you. Bye.